Isaac Newton was born on December 25th, 1642, in a small village called Woolsthorpe in England. He is one of the most famous scientists in history. Newton made many discoveries in science, including the laws of motion and the law of gravity. His work changed the way people understand nature. He also invented calculus, which is a type of math used to study things that change. Newton's ideas made him a key figure in the scientific revolution. Newton worked in physics, math, and optics. He studied how objects move and why. He also studied light and color, showing that white light is made of all colors. His book, Philosophiae Naturalis Principia Mathematica, The Mathematical Principles of Natural Philosophy, is one of the most important works in science. This book introduced his three laws of motion and explained the idea of universal gravitation. These ideas helped form the foundation of modern physics. Newton's discoveries still influence science today. His work helped explain how the planets move around the sun. He also created tools like the reflecting telescope. His ability to solve problems and think deeply made him one of the greatest minds of all time. People remember him as a brilliant thinker who changed science forever. Newton's ideas are still used in schools and science labs. They are a big part of what we know about the universe and how it works. Isaac Newton was born in 1642 in Woolsthorpe, a small village in England. His father died before he was born, leaving his mother, Hannah, to care for him. Newton was a very small baby, and many people thought he would not survive. Despite this, he grew up strong and lived for 84 years. When Isaac was 2 years old, his mother married again. She left him to live with his grandmother while she moved to a nearby village. This separation from his mother was hard for Newton. He felt lonely and angry about being left behind. These early events shaped his personality and made him very serious. Newton went to a local school, but showed little interest in farming, which his family wanted him to learn. He preferred reading books and building simple machines. As a boy, he made mechanical toys, sundials, and even a small windmill. His talent for building things showed his creative and curious mind from a young age. When his stepfather died, Newton's mother returned to Woolsthorpe and wanted him to manage their farm. But Newton was not interested in farming. Instead of working on the farm, he spent his time studying and reading under trees. He often forgot about his farm duties, focusing on learning instead. Seeing his lack of interest in farming, his family decided to send him back to school. He began studying again at Grantham Grammar School. At school, Newton was an excellent student. He learned Latin and gained a strong foundation in classical studies. This would help him later at university. In addition to schoolwork, Newton enjoyed building models of machines and testing how they worked. He often thought about ways to solve problems. By 1661, Newton was ready for university. He left his hometown and went to Trinity College, Cambridge, to begin his studies. Isaac Newton joined Trinity College, Cambridge, in 1661. At first, his studies followed traditional ideas, especially those of Aristotle, a famous Greek philosopher. Universities at that time focused on older ways of thinking, like Aristotle's view of the universe. This was based on the idea that Earth was at the center of everything. However, a new movement in science was growing, called the scientific revolution. This movement encouraged people to explore new ideas about the natural world. Newton soon became interested in these new ideas. He started reading works by scientists like René Descartes, who described the universe as a giant machine. Descartes believed that everything in nature could be explained by the motion of particles, which were like tiny parts of a larger system. Newton kept notes in a book titled Certain Philosophical Questions, where he wrote down his thoughts about these modern ideas. In his notebook, Newton wrote, "Plato is my friend, Aristotle is my friend, but my best friend is truth." This showed his belief in discovering facts over following old ideas. Newton also studied the works of Pierre Gassendi, a French thinker who believed in atomism. Atomism is the idea that everything is made of very tiny particles. These new ideas about matter and motion helped shape Newton's thinking. He began to explore questions about the laws that govern the universe. During his time at Cambridge, Newton started teaching himself advanced mathematics. He read works by Descartes and also studied classical geometry. He quickly mastered these subjects and began creating new methods for solving problems in mathematics. One of his greatest ideas was the binomial theorem. By 1664, Newton's studies had shifted completely to modern science. His passion for learning and discovery marked the beginning of his scientific career. In 1665, the Great Plague forced Cambridge University to close. Newton returned to his family home in Woolsthorpe and spent 2 years studying on his own. This time became one of the most important periods of Newton's life. Free from distractions, he focused deeply on math, physics, and astronomy. During these years, Newton laid the foundation for many of his greatest ideas, including the development of calculus and his study of gravity. One of Newton's key discoveries during this time was his work on light and color. He used a prism to separate sunlight into different colors, proving that white light is made of all colors. This was an important breakthrough in optics, a field that Newton continued to study for many years. His experiments with light changed how scientists understood it. Newton also began thinking about how objects move and why they fall to the ground. These ideas would lead to his famous law of universal gravitation. Newton observed an apple falling from a tree, which made him wonder why objects always fall toward the earth. He realized that a force must act between objects. This force, which he called gravity, is what keeps the moon in orbit around Earth and the planets in orbit around the sun. Newton worked out that this force becomes weaker as the distance between objects increases. This idea is known as the inverse square law. Newton also developed calculus during this time, which he used to solve problems about changing motion and areas under curves. This math became a key tool in science. Using his knowledge of motion and gravity, Newton studied how the planets move. His work built on the ideas of earlier scientists like Kepler and Galileo. By 1667, when Newton returned to Cambridge, he had already made discoveries that would change science forever. His time during the plague years was incredibly productive. After returning to Cambridge, Newton continued studying light and color. He delivered lectures about these topics and showed his experiments to students and scholars. Newton proved that light is not simple but made of many colors. He used a glass prism to separate white light into a rainbow of colors. This experiment showed that colors, like red and blue, are part of white light. This was a new idea, as people once believed light was only one uniform thing. Newton believed that light consists of tiny particles called corpuscles. He thought these particles traveled in straight lines and created the colors we see. His study of light became the foundation for a branch of science called optics. His work explained how rainbows form and how lenses bend light. Newton's experiments showed that light could not be changed or purified. This helped prove that colors come from separating light, not modifying it. To study light further, Newton invented a new kind of telescope called the reflecting telescope. This tool used mirrors instead of lenses to make images clearer. Newton's telescope was smaller, but gave a sharper view than earlier telescopes. The Royal Society was impressed and asked to see his invention. This telescope made Newton famous and helped him share his work with other scientists. It also marked the beginning of his close ties with the Royal Society. Newton's work in optics helped answer questions about how light and vision work. He published his findings in a book called Optics, which became very important. In this book, Newton explained his experiments and the conclusions he drew from them. His work in optics influenced many scientists who came after him. By studying light, Newton showed that nature follows clear rules, which can be tested and understood. This idea became a core part of modern science. In 1684, British astronomer Edmund Halley visited Newton with a question about planetary motion. This meeting led Newton to write his most famous book. Newton wrote a short paper first, called De Motu, on motion. He then expanded this into a larger work called Philosophia Naturalis, Principia Mathematica. Often called the Principia, this book explained the laws of motion and the law of universal gravitation, which became the basis for modern physics. The first law of motion states that an object will stay at rest or in motion unless a force acts on it. This explained why things don't move unless pushed or pulled. The second law of motion shows how force, mass, and acceleration are connected. It explains that stronger forces make objects move faster or change direction more. The third law of motion is about action and reaction. It says that every action has an equal and opposite reaction, which explains how forces balance. Using these laws, Newton studied how objects move in circles, like planets around the sun. He found that gravity pulls objects in and keeps them in their paths. He also proved that the same force of gravity applies everywhere, not just on Earth. This was a new idea at the time and changed how people saw the universe. Newton calculated that gravity weakens with distance. This is called the inverse square law and helped explain why planets move in elliptical orbits. Halley helped Newton publish the Principia in 1687. The book became a key text in science and showed that the universe follows laws that can be described with math. Newton's ideas in the Principia explained not just motion on Earth, but also in space. His work united physics and astronomy in a single theory. The Principia was praised as one of the greatest scientific works ever written. It confirmed Newton's place as one of the most brilliant scientists of all time. Despite his success, Newton faced many challenges in his personal life. He had difficulty accepting criticism and often reacted strongly to it. One major conflict was with Robert Hooke, a scientist at the Royal Society. Hooke disagreed with some of Newton's ideas about light and colors. Hooke accused Newton of stealing his ideas. This made Newton very angry, and their arguments lasted for years. Newton even tried to avoid Hooke whenever possible. In 1687, when Principia was published, Hooke claimed Newton used ideas he had first thought of. Newton denied this and removed Hooke's name from the book. Another problem came when Newton shared his findings about calculus. A German mathematician, Leibniz, also claimed to have invented calculus. This led to a bitter argument over who was the real inventor. The argument continued for many years, with people taking sides between Newton and Leibniz. Newton's emotional reactions to conflicts often caused him to isolate himself. For years, he withdrew from public life and avoided working with other scientists. In 1696, he accepted a government job as warden of the Royal Mint, where he focused on stopping counterfeiting. This brought him some peace. However, Newton never fully escaped disputes. His conflicts with other scientists, combined with his intense personality, made his life both remarkable and difficult. These challenges shaped Newton's later years. Even though he struggled with personal issues, his work remained groundbreaking and changed the course of science. Newton's determination to prove his ideas and defend his reputation showed his strong will. However, his anger often hurt his relationships with others. Despite these struggles, Newton's legacy as one of the greatest minds in history remains untouched. His contributions to science still inspire people worldwide. Isaac Newton's work changed the way people think about the world. He showed that the universe follows clear and predictable laws that can be understood through science. His 3 laws of motion are still taught in schools today. They help explain everything from how cars move to how rockets travel through space. Newton's law of universal gravitation became the foundation for studying planets, stars, and galaxies. It also inspired later scientists like Einstein to explore new ideas. Newton's invention of calculus provided a powerful tool for solving problems in science and engineering. It has been used to make advances in technology and medicine. His studies of light and color led to the creation of new tools like the reflecting telescope, which is still used in astronomy today. Newton's book, Principia Mathematica, remains one of the most important works in science, influencing many fields beyond physics, like engineering and space travel. Beyond his discoveries, Newton also helped establish a scientific way of thinking. He showed that careful experiments and math could explain how nature works. This approach became the foundation of modern science and helped spark the Industrial Revolution, which changed the way people live and work. Newton's achievements remind us of the power of curiosity and determination. His work continues to inspire scientists, engineers, and thinkers all over the world. Newton's life was not easy, but his passion for learning and solving problems left a lasting mark on humanity. His name is remembered as one of the greatest in history. Today, Newton's ideas still guide research in physics, mathematics, and space exploration. His contributions helped shape the modern world we live in. Through his work, Newton showed that even the hardest problems can be solved with patience, creativity, and a deep love for knowledge.